Okay guys, so the drill today is a mixed review for your quarterly. We're basically starting today, going to be reviewing for your quarterly. You will get your study guides at the end of the class when you finish up the scavenger hunt. We just have one more notes little video that I'll be doing with you today on writing inverses, which is basically something we've been doing the whole time anyway. Let's take a look at this drill to start though. Number one is a review of synthetic division. You will see synthetic division at some point on your quarterly. So let's take a look. The question says, examine statements 1, 2, and 3 below. They're right here. Which of them are true? So let's see. X plus 2 is a factor of the polynomial. Let's go over the pieces. Again, this is the 0 or the root. Remember, we use that. And if this number is the 0 or root, the factor is the opposite of that. So this must be the factor that we're dividing with that polynomial. So there's no way that number 1 can be true for that reason. But you could see number 2 has to be true. Whatever number this is, that is the 0 or the root. So number 2 is true. The third one, it is a factor of the polynomial. That depends on when we attach the variables. So remember, this is your remainder. This would be your constant, so no variable. This would be your x, and this would be your x squared. So if we rewrite that over here, that would look like 1x squared minus 2x minus 1, and a remainder of 0. So yes, this is another factor of the polynomial. So over the next couple classes, we'll review synthetic and log division. We're going to go back and review that because both of those are going to be on your quarterly. So most recently, talking about logs, let's take a look at number 2. Expand this in 3 different ways. So remember, 3 different ways could be the long way, short way, could be partially, so that kind of thing. Personally, the first way I'm going to do is the shortcut way. So that's where you subtract the exponents. So 2 minus 1 is 1. So we have log x to the first. And 1 minus 5 is negative 4. But you don't want to leave y to the negative 4. You want it to be a positive power, so you have to bring it to the denominator. And then this constant of 4 would just stay down here. So this is what I'm going to expand now. So I'm going to have log x minus, parentheses, log 4 plus 4 log y. That's one way. Or I could rewrite it with the 2 minuses as equivalent. There's another way. You could also, again, not even do the shortcut, and you could try to expand it the long way, which again just means be careful. So start with either the parentheses and pluses, like that, or looks like that. All of these, 1, 2, 3, are all equivalent to each other. It just depends on which way you prefer. Okay, so you'll be trying to find equivalent expressions when it comes to your quarterly as well. So all with expanding the logs. Let's take a look at number 3. Number 3 goes into the graphs. So I put the link on to Google Classroom to talk about the graphing of logs. If the link for whatever reason did not work for you, I also posted the actual video. It probably would not have worked from a phone depending on what it was, so you should have taken the time to go to a computer. Okay, you have Nest and things like that, and kind of look it up. So let's talk about it. It says, which of the following are true? Select all that apply. Now, first thing is, let's go back. Okay, so what the video said is you have a log function. These have vertical asymptotes, not horizontal, and your vertical asymptote is always x equals h. So you set that equal to 0, and that makes your vertical asymptote of the graph. This, okay, and this just determine the shifts but the vertical asymptote comes from the h, okay? So let's take a look here. There is a vertical asymptote at x equals -4. Well, if I was to set this equal to 0, I only get x equals 4. Okay? So clearly, A is not true. The parent function is log base 3 of x. When it says parent function, it means without any numbers, so kind of put your finger over it. That would be the parent function. If there were no h and k, log the same base of 3 in x, so that is true. The horizontal asymptote is y equals 2. There is no horizontal asymptote for logs. That is an exponential graph. Now, this is what we're going to be talking about today, showing in the video. This right here, put a little star. When you see this f of -1, that stands for the inverse. So if you kind of skip this one, I understand. We're going to come back to this so you can kind of see if whether it's true or not. I will tell you, if you notice here, see how this was a +2 and it's a minus. This was the k, now it's the h. This was the h, now it's the k, and they're opposites. That is true. That makes them inverses. Again, we will go over this today with the second video to kind of get you a better idea, and we'll practice it some more. We talked about in the video this end behavior stuff. So since logs have a restriction because of the vertical asymptote, we don't worry about that left side, we only worry about that right side. So when it comes to the right side of the graph, the logs will look something like this. So yes, y, this right here, will be increasing each time. So that is true. Like I said, we're going to come back and do the inverse video after this. Last but not least, with your calculator, find the local max and min of the function. So what would it take to minimize or maximize? So you need to type that into your y equals, so that needs to be your first thing. So let's type this function in. Now you had a sheet a while back that reviewed this, and we didn't do a whole lesson on it because it was just a sheet of directions on how to type it in the calculator, because you did this from Algebra 1. Then remember, you want to hit zoom 6 to kind of see the window. Remember, the change of direction are your min and max. So this right here is your local minimum. Okay, this is the minimum point. That right there is the maximum. To find them in your calculator, you don't have to show any work. You hit second trace. Second trace. Let's find the maximum first, since that's the first thing on there. Remember, when you see that, it says left bound, so you need to get to the left of the maximum, anywhere to the left of it. Once you do that, you hit enter. It will tell you right bound. So you must scroll to the right of it, anywhere to the right of it, and then you hit enter, and then enter one more time, and it will give you the maximum point right there. So in this case, our local maximum is 0.2, 5.2. Minimum is the exact same, except you move the cursor over to here. So second trace, minimum, get to the left side. So I'm left of it, enter, get to the right side, I'm to the right of it, enter, hit enter one more time, and there's my minimum. Now we'll continue to practice these calculator skills as well and all these different topics over the next couple of class periods. But for now, what you're going to be doing is there'll be a second video, and we're going to talk about what number 3 had from the drill, writing these inverses, okay? Writing a log to exponential because they're inverses. So we're going to do this next.